Very few emerging technologies hold the same promise as nuclear fusion. Effectively, limitless clean energy would be a complete game changer for the human race. One method for nuclear fusion, called tokamak, is a donut-shaped vacuum chamber encompassed by magnetic coils. These coils suspend plasma, which can reach temperatures of over 150 million degrees Celsius. This approach presents a difficult technical problem. How do we control the magnetic coils to keep this profoundly hot plasma suspended so that it doesn't collide with the chamber's walls? Deepmind created a reinforcement learner to do precisely this. It discovered how to control the coils to maintain the suspension of the plasma and even sculpt it into specific shapes, unlocking the capability for scientists to perform new varieties of experiments. Distinguishing between real and fake human faces has become effectively impossible with the advent of technologies such as StyleGAN 2. A study involving 223 participants found deepfake faces indistinguishable from real faces. Even participants in the study who received training on identifying generated faces saw very little increase in performance. Perhaps most remarkably, artificially generated faces were rated 7.7% more trustworthy than real faces. Researchers remain unsure why this phenomenon occurs, since there appears to be no explicit smoking gun. Implications of this finding include national security threats, fabricated news reports, and video and still images being used as evidence. Aspinity has developed what it believes is the first ever analog machine learning chip. The AML100 performs tasks in an ultra-low power setting through its ability to determine data relevancy with a high degree of accuracy at near zero power. This offsets the costs which result from other always-on systems spending large amounts of energy churning through primarily irrelevant data. In addition to this, the chip features field programmable functionality, an architecture with growing relevance to many ML applications. If automation is essential to unlocking new levels of productivity within industry, then automating automation is something akin to the Holy Grail. But why hasn't the discovery of deep learning architectures to handle specific problems already been automated? Consider all the variables and ranges and step sizes when discovering the ideal deep learning network to handle a task. Then think of how resource-intensive and time-consuming training networks with all these different parameters can be. Researchers at Alibaba are using gradients to approximate the performance of randomly initialized architectures. In more technical language, they discovered the gradient kernel can predict the accuracy before the model completes training. Their method, called Kernel Neural Architecture Search, consumes an order of magnitude fewer resources by calculating the gradient kernel as an initial pass before evaluating the best models for their actual accuracy. If you wanted to discover the overall composition of the universe, where would you start? This isn't a trick question. You would probably want to start by examining as much of the universe as possible. Well, it turns out you can also discover the composition of the universe by looking at just a single galaxy. This is a completely different idea. Instead of measuring these millions of galaxies, you can just take one. It's really amazing that this works. The mechanism works by feeding the machine learning system a series of properties for a particular galaxy, and then asking it to predict specific cosmological attributes. The scientists have evaluated the method across 2,000 digital universes containing between 10 to 50% matter. These universes were allowed to reach a state of maturity where galaxies had formed. At that point, any individual galaxy could be used to predict the density of matter to within 10%. This is an example of a deep learning method inferring a relationship thought to be impossible before its application.